Hello wonderful person, this is Anton, and welcome to the Red Planet. This is Mars. Now, have you ever wondered why Mars is so red? Well, let's actually find out in this video. Welcome to What the Math. So it's not really red, it's more of a orangey tomato kind of a color. Well, but there's still a reason for this color, and there's actually a really interesting reason that also suggests some other things about this beautiful planet. So let's actually talk a little bit about science of Mars. But before we talk about the science of Mars, let's maybe go back in time when Mars was not red. We're going to create Proto-Mars. And so this is actually what Mars may have looked like about 4.5 to 4.2 billion years ago. It was actually a very terrestrial-like planet with liquid water on the surface, with potentially even life. Now, we don't really know if there was life. As a matter of fact, we haven't really detected any signs of life just yet, but it's possible. But we do know that there was liquid water, and a lot of it. Now, if there was so much water before and if the planet looked so different, what actually happened to it? How did it turn so red and where did the water go? Well, something like 4.2 billion years ago, something started happening on the inside of Mars. As a matter of fact, this something was because Mars is not a very large planet. If we compare this to our own Earth, this is actually what it looks like. It's much, much smaller, and it's also less massive. It started to cool down very quickly, and the inside of the Martian planet started to basically solidify. And because the inside of Mars started to solidify and were no longer as liquid, there was something very important to start happening to it. Its magnetosphere started to slowly disappear. And as it disappeared, it basically started to lose a lot of the protection that stopped the really dangerous solar radiation from stripping Martian surface of atmosphere and water. And essentially, well, you can kind of see what actually happened in this little simulation from NASA. Essentially, what started happening was that first Mars started losing atmosphere. And what essentially started happening is these super powerful radiation streams from the sun started hitting the planet and stripping its surface of everything. So all of the water and all of the atmosphere started to slowly escape over time. And as that happened, the layer of water and the layer of atmosphere started to decrease. And it didn't take very long for all of this to basically disappear. And we're going to simulate this very easily. So as soon as the atmospheric pressure started to decrease, over time, basically the atmosphere thinned so much that there was really nothing protecting the surface from the dangerous solar radiation. And as soon as that happened, the sun started hitting the water. And at the same time, the water here could not exist in liquid form anymore because there was just not enough pressure. So it started to become either gas or transformed into ice form. And so there is that water turning into ice. And basically, at this point, the solar particle that I'm going to try to recreate again, every time they hit the surface of Mars, so every time that this radiation jet is going to hit the surface, is now going to break water apart. As a matter of fact, it's going to turn water into two molecules, hydrogen and oxygen. Now, hydrogen is very, very light, so it will actually escape and fly away and leave the Martian system. However, oxygen is actually relatively heavy, so oxygen will actually start to deposit on the surface of the planet and start interacting with various elements, specifically iron on the surface. Now, what happens when you combine iron and oxygen? Well, that's rust. Rust is created. And what color is rust? Rust is, of course, red. And that's how essentially over time Mars turned into a much redder, more rusted planet that it is today, and essentially started to look similar to, I guess, this, but maybe a little bit different. Now, this is actually a very important observation because what this suggests is that, oh yeah, by the way, before we continue, Mars also received a very interesting collision from a very large asteroid that hit its northern surface that actually flattened the shape of Mars, where the north now is a lot more flattened than the south. But this happened hundreds of millions of years after it lost its atmosphere and water. As a matter of fact, it happened even after it transformed completely. So it didn't really affect the Martian surface that much, although it might have actually brought even more water than it currently has. And where's our asteroid? Well, here it comes. It's going to be coming from the north. And so anyway, so what is so important about this observation? Not about the asteroid, but about the fact that this is how Mars lost its atmosphere and how it became red. Well, it suggests to us that in the future we might be able to find planets, exoplanets that have oxygen on them. Normally, oxygen is really only created by life. This is how we know oxygen came about on Earth, and this is exactly what we would expect to see if there was any kind of a similar life somewhere outside in the in our galaxy where we can find a planet that has oxygen. But Martian observation suggests that oxygen can also be created without the life. If there is water on the surface, we might actually find an exoplanet somewhere out there. For example, let's just pick one here. For example, Proxima b, the nearest exoplanet to us. So maybe, just maybe, Proxima b actually has oxygen on the surface. But we might actually need to wait and not make any conclusions about life on this planet, because it might be coming from the fact that the water level, or the ice water here, is slowly being broken down into constituent particles into its atoms, and as it's broken down, it basically turns more and more red and basically rusts on the surface. So if this actually happens on other planets, and if we actually detect oxygen in their atmosphere, what we've discovered is essentially yet another Mars. We've discovered a planet that used to have water and now is losing water because it doesn't probably have enough magnetosphere to protect it from the radiation from its star. On the other hand, what this also means is that we might actually be able to find a planet that has very Earth-like conditions. It might even have a lot of water on the surface, but what it will not have is magnetosphere. So even though it might have atmosphere and actual liquid water on the surface that is needed for our survival, that you're about to see in a few seconds as soon as this planet warms up, it will not, however, have the magnetosphere to protect us, which is very, very important on our planet, and without it, we won't be able to really survive on that particular planet for a very long time. And anyway, so that's essentially how our beautiful neighbor Mars became so red, and this is its history in a nutshell. Hopefully you learned something from this video, and hopefully now you know a little bit more about Mars and a little bit more about the rusting of planets, and of course a little bit more about oxygen and why it's not essentially an indicator of life if we discover it somewhere else in our galaxy on one of the exoplanets. Let's actually bombard Mars for a little bit just because it looks so beautiful. And while I'm doing this, don't forget to subscribe if you still haven't. Share this video with someone who enjoys watching various space videos and wants to learn through video games. In the next video, we're going to discover something else about something completely different, so come back tomorrow to learn something new. I'll see you guys tomorrow, space out, and as always, bye-bye. Well, Mars, it was nice knowing you.